Somewhere over the Indian Ocean, a machine the size of a 20-story building is falling out of the sky at 20 times the speed of sound. It is wrapped in plasma hot enough to vaporize steel. And bolted to its skin are roughly 40,000 ceramic tiles, each one hand-fitted, each one a single point of failure. 6 of them have been painted white. Not because they're damaged, because SpaceX wants them to look damaged. A deliberate lie, stitched into the hull so that 20 satellites watching from a distance can learn to tell the difference between a scar and a shadow. This is the story of Starship's 13th flight. Not the launch, not the explosion that didn't happen, the quiet experiment riding along with it, the one that might decide whether this rocket ever comes home. Everyone who follows Starship knows the highlight reel. The catches, the explosions, the size of the thing. Almost nobody talks about the actual bottleneck standing between SpaceX and a fully reusable rocket, and it isn't the engines and it isn't the booster, it's the tiles. Elon Musk has called the heat shield the single biggest unsolved problem in the entire program. Not because ceramic tiles are exotic technology. NASA solved atmospheric re-entry with tiles on the space shuttle in the 1980s. The problem is scale, and the problem is inspection. The shuttle flew with roughly 24,000 tiles, and after every single flight, technicians spent weeks, sometimes months, walking the vehicle by hand, checking each one. Starship carries nearly 40,000 tiles across a hull that's meant to fly again within hours, not months. You cannot hand-inspect 40,000 tiles on a turnaround timeline measured in hours. That math simply doesn't work. If SpaceX wants Starship to be reusable in the way a commercial airliner is reusable, refuel, recheck, refly, someone has to invent a way to know at a glance whether the heat shield is flight-ready. That's the quiet, unglamorous engineering problem sitting underneath every headline about Starship, and Flight 13 was built, in large part, to attack it. Before we get to the flight itself, it's worth sitting with how close this mission came to not happening at all, twice. Flight 13 used a new booster, designated Booster 20, and a new ship, Ship 40, the second flight of Starship's third major design iteration, known as V3. The first V3 flight, back in May, had been rough. The ship suffered an engine failure during ascent, and the booster failed its boostback burn after separation, missing its landing entirely. SpaceX spent the following months investigating that failure before the FAA would clear another launch. That clearance came on July 13th. 3 days later, on July 16th, SpaceX rolled Booster 20 and Ship 40 to the pad for the first launch attempt. At T-0, the exact instant of ignition, the countdown stopped itself. 4 of Super Heavy's 33 Raptor engines failed to reach acceptable starting parameters in the final fraction of a second before liftoff. The flight computer did exactly what it was built to do. It aborted automatically, safed the vehicle, and stood the rocket down before a single one of those engines could fail in flight, sitting under a fully fueled booster. It was the first full-stack ignition abort in the history of the Starship program. SpaceX's own postmortem pointed to the oxidizer turbopumps, likely a moisture-related issue that prevented several engines from spinning up correctly. 2 engines were pulled and replaced. Musk suggested a relaunch early next week. It took longer than that. A second attempt, on July 23rd, was scrubbed with less than 3 hours left on the clock. Not because of hardware, but because of weather, as Tropical Storm Bertha pushed through the region. So by the time Starship actually lifted off on July 24th, it had already survived 2 scrubs, an unprecedented pad abort, and a named storm. The flight hadn't even started, and it had already been tested. At Orbital Launch Pad 2 in Starbase, Texas, on July 24th, all 33 Raptor engines on Booster 20 lit cleanly, no aborts, no holds. For the first several minutes, this looked almost routine, which for Starship is itself remarkable. Both stages made it through max aerodynamic pressure and staged cleanly, with no engine outs on either the booster or the ship. That's a meaningful data point on its own. Flight 12's ship had lost an engine during ascent. This time, all engines on both vehicles performed through separation. About 7 minutes after liftoff, Booster 20 executed its boostback burn, the maneuver that reverses the booster's trajectory and sends it back toward a landing zone, and this time, unlike Flight 12, it worked. The failure that had doomed the booster in May did not repeat itself, but the story of Booster 20 wasn't finished. It had one more burn to complete, and that's where things got interesting. Here's a detail worth getting precisely right because it's the exact kind of thing that gets misreported. Booster 20's boostback burn, The one that failed catastrophically on Flight 12 worked perfectly on Flight 13. The problem this time happened later, during the final landing burn over the Gulf of Mexico. Of the 13 engine's super heavy uses for a landing burn, 8 failed to relight properly. The booster still came down under control, but it hit the water harder than SpaceX would have liked, a hard splashdown in the words of the livestream commentary, rather than the soft, controlled touchdown SpaceX has demonstrated on land at the launch site. It's tempting to file that under failure. It isn't, and here's why. This booster was never going to be recovered. SpaceX has already demonstrated it can catch boosters back at the tower on flights 5, 7, and 8, with 2 of those boosters later reflown. Booster 20 was always headed for a one-way trip into the Gulf, expendable by design for this test. A rough splashdown on a vehicle that was going to be discarded either way tells you engineers still have tuning to do on landing burn engine restarts, useful information, but it does not represent a mission failure, and it has nothing to do with the boostback maneuver that failed catastrophically 2 flights ago. This is precisely the kind of distinction that gets lost in casual coverage. The booster splashing down hard is not the same event, and not the same failure mode as the near disaster in May. 2 different burns, 2 different problems. Only one of them repeated. While Booster 20 was falling toward the Gulf, Ship 40 was doing something no Starship had ever done, releasing an operational payload. 20 next-generation Starlink V3 satellites rode inside Ship 40's payload bay, the first time this satellite generation had ever flown to space. Once clear of the ship, each satellite extended its solar arrays and antennas and attempted to link into the broader Starlink constellation, both over standard radio links and over intersatellite laser links. Every single one succeeded. SpaceX confirmed contact and laser connectivity with all 20. Here's the part that sounds like a footnote, but is actually the entire point of the mission. None of those 20 satellites were built to stay in orbit. Because Flight 13 flew a deliberately suborbital trajectory, every satellite it released was riding the same falling arc as the ship itself. Roughly 20 minutes after deployment, all 20 burned up in the atmosphere, exactly as planned. SpaceX spent real money building 20 functional satellites, launched them into space, confirmed they worked, and then let all of them burn up on purpose 20 minutes later. That's not waste. That's the experiment. 6 of those 20 satellites carried something the other 14 didn't. Cameras, specifically aimed backward at Ship 40, tasked with one job: watching the heat shield during re-entry, and beaming that imagery down to engineers on the ground in near real time. And this is where the painted tiles come back in. Ahead of launch, SpaceX crews deliberately painted several of Ship 40's black thermal tiles white. Artificial damage, engineered on purpose to give the camera satellites something to find. It's a calibration test disguised as vandalism. If the inspection system can correctly flag 6 tiles that were never actually damaged, engineers gain confidence it can also catch real damage on a future flight, from orbit without a human ever laying eyes on the hardware in person. Layered on top of that, engineers instrumented a number of tiles with sensors to measure structural stress under higher dynamic pressure than previous flights. Not because they expected the tiles to fail, but because they're trying to validate margins that would eventually let Starship carry more payload without exceeding the heat shield's structural limits. Musk later said the flight produced more heat shield data than the team had expected going in. For a company whose CEO has openly called the heat shield the program's biggest remaining problem, that's not a minor result. That's the headline the mission was actually built around, even though it never once made a breaking news chyron. 39 minutes into the flight, Ship 40 did something Flight 12 never got to attempt. It relit a single Raptor engine in the vacuum of space. Flight 12's ship had lost an engine during ascent and had to abandon this exact test. This time, the relight worked cleanly, a small maneuver, but a critical one, since any future mission that needs Starship to circularize its orbit or head to the moon depends on engines being able to restart reliably once they've already fired and shut down in space. Then came re-entry. Ship 40 hit the atmosphere and endured the plasma phase of descent, the part of the flight where superheated, ionized air surrounds the vehicle and briefly cuts off communication without any visible structural issues. It executed its now familiar belly flop and flip maneuver and began its final descent toward a predetermined splashdown zone in the Indian Ocean near a set of buoys fitted with Starlink ground terminals specifically positioned to keep receiving telemetry through the final seconds. The landing burn sequence itself was a study in deliberate deceleration. It began with 3 engines firing, then dropped to 2, then to 1. a step-down burn designed to shed most of the vehicle's velocity immediately after the flip, before using a single engine to control the final gentle touchdown. It worked. Ship 40 settled into the Indian Ocean roughly an hour after liftoff on schedule, and for the first time in the program's history, stayed intact. It didn't break apart on impact. It tipped gently onto its side and floated, engines and flaps still visibly attached, cameras still rolling, still transmitting live telemetry back to SpaceX's control room from the surface of the ocean. SpaceX's own spokesperson, watching the feed live, called it the softest splashdown the vehicle has ever achieved, a dream scenario for a team whose entire job that day was recovering heat shield data. It's worth pausing on how strange that sentence is. If you say it plainly, a multi-hundred-foot rocket deliberately crashed into an ocean is the good outcome. That's not irony. That's exactly how a suborbital test flight is supposed to end. Controlled, intact, instrumented, and floating long enough to finish talking. So, 13 flights in, where does this leave the program? Starship still has never completed a full orbit of Earth. Every flight so far, including this one, has been intentionally suborbital, a controlled, cautious approach that lets SpaceX gather data without risking an uncontrolled re-entry over a populated area. That's not a failure of ambition, it's the deliberate, patient shape of a flight test campaign. What Flight 13 actually delivered was narrower, and arguably more valuable than a headline number like orbit would have been. A clean stage separation, a successful boostback burn, confirmation that 20 Starlink V3 satellites can deploy and phone home reliably, a working in-space engine relight, and, the heart of it, the first real dataset on whether a heat shield's condition can be assessed remotely, from a passing satellite without ever bringing the vehicle back to a hangar first. That last piece is the one that actually unlocks the future. SpaceX has already caught boosters at the tower. It has not yet attempted to catch a returning ship. Before that happens, the company needs to trust that the heat shield underneath the vehicle survived re-entry, and trust it fast enough to make a same-day turnaround plausible. A 6-satellite camera constellation, calibrated against a handful of deliberately mispainted tiles, is the first real attempt at building that trust. 13 flights in, Starship still hasn't completed an orbit. But for the first time, it came home intact enough to tell engineers exactly why that matters, one painted tile at a time. If you want the next flight broken down with this level of detail, the moment the data comes in, subscribe to Overlooked Space, and let me know in the comments which part of this mission you think deserves more attention than it's getting.